Hello everyone, in this video we are going to learn about system calls and how to implement this. In this video we will be demonstrating three system calls, that is list PID system call that will list PIDs, shutdown system call that will close the xv6 terminal QMO, and a parent that will do a fork and then print the child and the parent from each individual processes. So these are the three system calls that will be implemented in xv6. Now let us come to the first system call, that is list PID.c. So to implement the system call, first of all we have made a list PID.c program, and then we are calling, as per we can see here, the GetAllPids system call. So now to see how this works on, first of all we will go to the GetAllPids function and where it is declared. So first of all, the kernel, when we execute this list PID, it just goes to the user uses.s, and then here as we can see that it simply calls this assembly code. So what this assembly code is basically saying, that this is call name, so it defines a global variable, the name given for the whatever system call. In our case it is GetAllPids, so it will just make the name a global variable, and then it will move the sys underscore hash name, that will be sys underscore GetAllPids in the EAX register, and then it will call interrupt, that is int, don't be confused with integer. So it will call an interrupt $t underscore sys call, and this t underscore sys call is basically a global variable, that is global interrupt, that has the value of 44 or 64, I don't remember exactly. So it which tells the processor to interrupt, and then it returns. So let us see where now it calls when it moves the sys underscore GetAllPids, and let us see where we have defined the sys underscore GetAllPids. So the sys underscore GetAllPids is basically defined in user program, that is syscall.h. So here it is defined, has defined sys underscore GetAllPids as 22. So what the uses.s program will do, that it will just simply put the value 22 in the EX register, and then it will call the syscall.c function. System call is called from here basically, as we can see. So what it basically does, first of all let us see this syscall. We have defined something like that. So here this line sys underscore GetAllPids is basically defined to this sys underscore GetAllPids. So whenever a system call is there, so it will just simply see this line, that it will just simply push this on EX register, and what this is basically, that call the syscalls num, that is basically this sys underscore GetAllPids, and it will just simply call this function sys underscore GetAllPids, and it will call this as a function, and when this function will be called, this will be pushed on the register, and then it will be returned to the user. Now let us see that how this function, that is sys underscore GetAllPids, is implemented and where it is. So this is basically defined in the sysproc.c. Here as we can see there are many functions, sys underscore fork, that basically does a fork. Now our use is of the sys underscore GetAllPids. So here is our function sys underscore GetAllPids, which basically has a pstat type of struct pstat type of variable. So let us first of all see what is struct pstat. So basically struct pstat is a global structure which has this sum of this, as we can see, some of these properties like in use, whether the slot of the process table is in use or not, what is the PID of the process, what is the name of the process, what is this ticks, ticks, like the number of ticks each process has accumulated, the high or low priority, and other things that we can include in this as we go on with our project. So now this is the pstat.h, and now how these values are filled, that will be seen in our proc.c. So what happens is that when this system call is called, that is the system underscore get all PIDs, first of all it defines a struct piece chat star st type of variable. And now let us see this line. What this line is doing is that, as we know from the user space, we can't simply pass variables or pointers to the kernel space. So what this is doing is that arg pointer is called. This will basically do some in memory or the kernel thing will happen, and this pointer will be basically returned not directly but indirectly in the user space. So here this thing is done for that whatever the sys underscore get all PIDs that was defined in the list PIDs, we got this get all PIDs and we pass it struct and st. So but we see here that this whatever was passed down here, the struct piece chat st, is not basically called here in this function, but with the help of arg pointer it will be basically the same pointer here. So even if we don't use a thing here, it just comes out to be correct. And now we will see what happens, that whenever a process is made or called, alloc process in the proc.c function is called. So what the alloc process does is some bookkeeping of the process. So here we see that it acquires a ptable lock, and if some slot is empty, then it simply puts the process in embryo state, that means it is now occupied, and it assigns a PID to that process. Now in this we have added our few lines of code here, this lines. What this lines of code is that for each process in the piece chat variable, put the corresponding values, like piece chat.inuse equals to 1, then piece chat.pid is basically the process ID, piece chat.name will be some name. Here we have, just for reference, it's 0, 1, 2 for each character, and then we have hticks and lticks for the process, and we have assigned some values here. So what will happen, that whenever a process is allocated, this alloc process will be called, and whenever alloc process is called, the piece chat values are basically automatically filled in. So whenever we call this sysproc get all PIDs function, so whatever will be there in piece chat for each of the processes, now we are passing this to our st struct piece chat st variable. Like we can see from here that st.init is equals to I, like nproc is basically a global variable which is 64 defined somewhere, and for that we have done this, like maximum of process, loop through each of it and then fill the space with this. Now this is done, and a return of 0 simply return. And now what will happen, that this pointer which is referenced by rp pointer in the user space is called in the system space, kernel space, sorry, and in this kernel space we fill in the available details for each of the processes. Now this function is returned back, as we will see in the list PID, that piece stat st is basically returned as a pointer here. Now get all PIDs, this piece st will contain all the relevant details for each process. Now we simply loop through n processes, and if though that slot of that particular piece that type st, if it is in use, we simply print out this st.pid, the PID of the process, the hticks and lowticks that are irrelevant in here because we want basically the PIDs, and we will obviously add more details to it. Now let us try and run this. So here we are in our xv6 public master. So let me first of all clear this, and now we will simply make qmove. So this ran here. Now this is also the same as the qmove. So now we want to try our program, that was list pid.c, the system called list pid.c. So we will simply type list pid, and we see that okay, first there are 3 processes, 1, 2, 3, but this was not filled in, the details were not filled in here, which it would be have been filled in the proc.c, but our relevant is the PIDs and all the processes are running. Now how to check this is the correct result? For that, let us see another system call which we are implementing, that is a parent system call. So what does the parent system call does is it basically calls another system call, that is for, which will create two processes, a copy of one of the process, and it will simply return this here. It will get PID system call. It uses the get PID system call for the process, and it also uses the get PPID, the parent ID of the process, and this is how it is implemented. Again, the relevant details, the relevant system call implementation will be same. The get PID and get PPID are defined in xv6 here. The get PID will simply return the process ID, while the get PPID will return the process.parent.pid. So now let us try and test the parent. So when we type get parent, we can see that okay, my child, my PID is 4, child ID is 5, my PID is 5, my parent ID is 4. So basically a new process is created, child ID of 5. Now let us again call our system called as PID. Now here we see that one more PID is added in our list of PIDs. That means that one more this function thus works, and it in fact produces the result as expected. The process ID 1 and 2 are some kernel variables. The 3 have changed to something in here because 3 was just some process running like list PID, so it didn't have. Now when we call the parent, it was just the parent. Let's suppose the parent had ID 4. Now when the parent ran, it created a new one, 5. So we can see that the 3 just got lost because the 3 was the ID of list PID. When it came to completion, then the list PID process just went away and we got lost of this PID. Now when this system call was implemented, a new process with PID, say as given here, it is 4, child ID is 5. So this is how it works, and the same applies here also. So now this is all about the system call. Now let us try our third system call, that is the shutdown.c. The implementation of shutdown.c is also simple, that it's simply calling a system call shutdown. Now what happens in system call shutdown, as we will see in here. Let me find out shutdown. Okay. So this is the shutdown system call. What it does is it basically prints a shutdown signal sent on the QMO, and then it sends a outw this command. Now this command is basically a well-known processor implemented, like it's something related to kernel. So what it does, that is basically a hexadecimal code which simply interrupts or closes the terminal. So not much detail will be thought about in here. We can always Google and find out what it does. And so basically shutdown. Now let us check out this system call. How does it work? So we'll just simply call the shutdown system call. The shutdown system call was sent and the QMO just went off. Now see, we are back to our folder and just the QMO, our QMO got shut down and it got closed. So this was the basic of our implementation of system calls. Thank you.